Hello, everybody. I'm here with Franck Sidi, who's a Senior Director at Enterprise DB, to talk about analytics and AI in Postgres. So, Franck, thank you for joining me. I have a number of questions for you. So the first one is that really puzzles me. AI and analytics. Are those actually two different things? Are they two different sides of the same coin? Are they two extremes on one dimension? Help me understand that.
So first of all, Marc, thank you for inviting me. It's a pleasure today to be with you. So analytic and AI, they are two different disciplines, but you have interesting overlap. So analytic organizations are doing analytic for decades. So it's mainly working with historical data, raw data, in order to gather insight, to find some pattern, and lately help organizations to take the right decision. So this is analytic. And you're about reporting, dashboarding, and this is what we call the traditional analytic. AI is a broader spectrum, so we talk a lot about AI today. So inside AI, we have machine learning, we have deep learning, and now we have generative AI. And AI enable lately machine to do tasks that usually are done or suitable for by the human brain. And so that's the main purpose of AI. But of course, you have some interesting overlap, and the interesting overlap, we can name it AI analytic, where you want to use AI to make your analytics smarter. So, and the traditional one is about predictive analytics, where you want to do forecasting, or if you want to use, for instance, a natural language processing capability for doing sentiment analysis. So that's at the end of the day, there are two different disciplines, but with interesting overlap.
Okay, thank you. So let's dive into analytics. I mean, in Postgres architecture, that's like 35 years old, right? It was designed for transactions. Can it support large-scale analytics, or does the architecture have to be extended?
So I will be very direct. I'm a big fan of Postgres, but we need to acknowledge that and by the way, when we are talking about large scale analytics, I recently read, a paper. We are talking now about exabyte data lake architecture. So Postgres even better than I. So that if you want to target large scale analytics, we have to do some change in terms of architecture. So if you want to scale, you need, first of all, to modernize the architecture, to have a separation in between compute and storage, because lately you can scale the compute in an independent way compared to the storage. You need to have also ability to scale out the architecture. So if you need to get to manage more data, you have ability to add additional machines. So that's another important dimension. Another interesting dimension is the way to handle, the query execution. So it's good to be able to scale the compute, but it's also important to have what we call a distributed query engine. So the one single query will be able to be executed on the multiple compute. So that's, I would say, the first dimension regarding the architecture. And then, when we're talking about analytics, and I start 30 years from now at Sybase, and Sybase was one of the precursors regarding columnar database, with Sybase IQ. If you want to manage analytics, you need to store the data in an efficient approach, and the columnar approach is the best one for analytics. So that's also an interesting dimension where we'll have to make some change. And the columnar is also not only interesting because you can store the data accordingly, you can have some smart optimization, the way you are going to store the information with some metadata in order to skip the block that you need to read, but also regarding the compression. So if you store the data per column, I can tell you can even get a 20-time compression ratio, which is something fundamental if you want to run large-scale analytics. So that's a few interesting dimensions. And lately, another important one is when you are running query execution is what we call vectorization. So I'm not talking about vector database related to generative AI, but more in the fact that if you store the data per column, you don't have any risk regarding mismatching whenever you are accessing the data in between the column, because if you are accessing the data in a raw format approach, you can have mismatch in between the data type. When you access the data using a columnar approach, whenever you read a column, you can leverage what we call a single instruction multiple data. So in one single CPU instruction, you can read multiple data. So they are, in my opinion, all the, I would say, the change that we will have to add inside Postgres in order to be able to manage large-scale analytics.
That's very interesting. So both the compression and the vectorization play on the fact that in a column, I will have the same data type, age, salary, whatever, right? Or geographic region. And the probability is that between the values in different rows in that same column, they're probably going to be very similar. So they compress. That compression ratio is really, really high, much higher than anything I can achieve. And you didn't mention it before, but I think the when we distribute the query, we also distribute the I/O, right? And distributing the I/O and compressing the data will greatly alleviate one of the bottlenecks, which is to get data in and out from the disk, right?
Yes, exactly.
Okay. So in this context, you didn't use the words, but I've heard a lot about, data lakes, data warehouses, and lake houses. I mean, is that just marketing hype, or is there something to it?
So no, this is not marketing hype. They are really what we call different data architecture. So when I start 30 years from now, and the data warehouse emerged, and the concept of the data warehouse was really to give opportunity to the organization to consolidate data from multiple operational systems, to do some transformation, to perform some aggregation, and to provide what we call the single version of the truth. So this was the data warehouse. So few challenges emerge with this type of architecture, even if we have multiple versions of the data warehouse. The first was, of course, it was mainly for managing structured information. You have issue regarding scalability. So this is why we had also lately the emergence of the data warehouse appliance, where the goal was to have, I would say, a stronger scalability. And you had also the point that it was not suitable for real-time use case, because you were processing the data in a batch approach. And lately, the target audience for the data warehouse was mainly the data analyst. So we were not even thinking about data scientists. I don't know the way we were naming data scientists at this time, but the platform was not suitable for the data scientists. So this is why in the beginning of the 2010 decade, and I'm pretty sure you remember about the Hadoop wave, we have this notion of data lake. So the concept of data lake was really to fix all the issue of the data warehouse, providing first ability to gather all the raw data. So, and not only a subset of the operational data after transformation, to open also the platform not only for the data analyst, but also for the data scientists. So opening the platform for different type of use case. And then there was an important dimension about the scalability and the cost, because the concept was to be able to scale using commodity hardware. You remember also HDFS, so pretty, I would say, low-cost storage format, in order to fix all the, I would say, the issue about the data warehouse. But data lake was an interesting concept. We still have a lot of data lake running today in the world, but they miss, a few important aspects. Number one, the complexity for implementing data lake, because you had a lot of framework. The second aspect was the data governance. So it was a nightmare really to manage data lake. And the third was the I would say they forgot to really focus on the why the data warehouse, and they were not able to provide the same quality of services that we used to have with data warehouse with the data lake. And this is why before the lakehouse emerged, what we call modern data warehouse, Marc. Think about Snowflake. Snowflake came and they completely, they start to make a revolution. They call it modern data warehouse, the split in between compute and storage, ability to manage also not only structured data, but also semi-structured data, and then providing SaaS services in the cloud. Okay, so that's the way we had the data warehouse, data lake, modern data warehouse, and now we have this notion of lakehouse. So this notion of lakehouse is really to have the best of all the world, having a platform where you can manage, what modern data warehouse can do, having a platform for the data scientist, having a strong data governance, and try to lower the cost and I would say the all about the operation on the platform.
That's interesting. So the lakehouse gives us the ability to have unstructured data, structured data, but also to analyze that in a way that is easy and accessible to somebody who may, just be running Tableau or something like that, to be able to get at the data and avoid the issue that I've sometimes heard named, data cesspools as, a description for certain data lakes where there was just no structure and it was almost impossible for the uninitiated to find anything.
Yeah, exactly. And think about even on some data lake today, you have two different SQL engines. So it means that there is not one really good. So the two, they are average or too complex. So this is why the concept of the lakehouse and what some of the vendors they are doing and what at EDB we will implement is, I would say, the right direction.
Good, thank you. So now, we're at the Postgres company, right? Or we're the major contributor to Postgres. Why are we having this discussion about analytics as, the major Postgres supplier? Why would I want to have Postgres as my analytics solution? Why not one of the best of breed solutions like, I don't know, BigQuery, Snowflake, or Databricks?
Sure. So first of all, we need to assess there are all the three very strong and solution for running analytic. They have also AI use case for sure. But they have a common pattern, all these three solutions. They are only running in the cloud, in the public cloud. And this is, a reality today that customers, they are not only looking for running analytic and AI in the public cloud, they are looking to have a hybrid cloud approach. So that's the number one reason. The number two, and I don't know if you will agree with me, so the same way Linux won the battle regarding the operating system and became the standard, we need to acknowledge that Postgres is also winning the battle regarding the database. So Postgres is becoming the standard. I'm not meeting a single company where Postgres is not one or part of the operational database inside the organization. So it means that we have a fantastic opportunity to ease the flow that I was explaining before in between moving the data from the operational system to the analytic. And this is why running analytic with Postgres, and if we can fix all the, I would say the topic we mentioned before is a, I would say, win-win approach for everyone.
Okay, so is that going to get us to the mythical HTAP type of system where transactions and analytics sort of happen inside the same box without any data pipelines, without any weekly loading of the data warehouse? Is that the promise here?
HTAP is indeed a real and interesting data architecture. So HTAP, just to explain to everyone, this is for hybrid transactional analytical processing. So in fact, it can be very interesting for real-time analytic use case, where, for instance, if you want to do fraud detection. But at the end of the day, from my perspective, it's very tough to have one single engine that can really manage accordingly, I would say, transactional and analytic. We discussed about columnar. You know that the best way to store information for transactional is in a row-oriented approach. You may have some issue regarding the concurrency because transactional usually you can have hundreds of thousands of concurrent sessions. For analytic, it's more about fewer sessions but larger and queries. So my view is I will favor a solution where you can have a dedicated transactional system, analytic, but you can completely automate the sync in between the transactional system and the analytic. And the cherry on the cake is if you can use the same language, if you can use the same, I would say, technology for the developer, it will really be a very strong benefit. Do you agree?
Yeah. So basically, you're saying, okay, we're going to run the transactions in Postgres. Yeah, we may have a little bit of a different engine under the hood to do complex queries, but both systems will talk SQL. Both systems will talk the same dialect of SQL and be easily understandable, trainable, etc. But each optimized for the different tasks and the different use cases, but connected synchronously in the back end. So we've talked a lot about analytics. Let's dive into AI, right? How does Postgres support that? I mean, when Stonebreaker designed Postgres 35 years ago, AI was a completely different thing, right? I mean, think Marvin Minsky was still around, etc. We were talking about roles and Prolog, etc. AI today is something completely different. How can the system that he designed at that time become the workhorse for AI today?
Sure. So just to tell you that I learned Prolog. So I don't know for you, but I remember learning Prolog with someone from the University of Marseille. So it was pretty interesting. I think, what was very interesting regarding the Postgres project. So even if, and I'm a big fan of Stonebreaker as well. So if he was not thinking about designing something for AI, he put in place the design principle to make Postgres also suitable for AI. And I can articulate. So the first important aspect is the extensibility of Postgres. But when I'm talking about extensibility, you will think first about extension. But I will start with what I call the extensible framework. Extensible framework, if I have to ask a question, what are the favorite programming language for the AI community? The answer will be
Python?
Python, yes. Yes. SQL?
Yeah, sure. Absolutely. Yes.
So guess what? You can create, first of all, you can manipulate natively all these data type inside Postgres, and you can use PL function, so in Python, in R, in SQL directly in the database. So you have this ability to run the computation directly where the data are. So, and if we are talking about AI, one of the most common today generative AI and NLP library named Transformer. You can use Transformer directly inside the database. So that's, in my opinion, number one regarding the ability of Postgres to be very suitable for AI. A second important aspect is I'm a big fan of data federation, so the foreign data wrapper. So this is something fantastic because not all the data, they are in the one single database. So you need also to have ability to access data externally. And this is what the foreign data wrapper is giving you. So that's a very strong advantage. The third, of course, is about the extension. When we are talking about extension, so the PG vector extension. So PG vector give you ability to manage natively vector inside Postgres. So do you know when PG vector extension has been initially created?
2 years ago? No?
2021. Okay,
really?
So yes. So and by the way, kudos and credit to Andrew Kane because he's really managing the extension in a very good way. I can tell you. So I made some search. So if you go on and again, I love the competition. I used to work on SQL Server, but take SQL Server, for instance, you still don't have vector data type support. If you go, we talk about Databricks or Snowflake. Databricks is supporting a vector through the Mosaic AI extension. So that's a different engine. So same for Snowflake, where they have some limitation. So I think the beauty of Postgres is really about this extensibility, ability to manage interesting extension like a PG vector directly in the database. And then we have some additional extension, especially regarding ML when we are talking about Postgres ML. And another project that I know very well is Apache Madlib. So that's, all the ingredients who are making Postgres really suitable for AI.
Interesting. Yeah. So you mentioned vectors a whole lot, right? Tell me more about vectors. And I think, the word similarity search there pops up a whole lot. So tell me about how that works and why that's central to AI.
Yeah. So, I think you're in the data business like me. We have same age. So, no, maybe I'm a bit older than you. But one of the challenge for when you are talking about database for decade was how to search and manage unstructured data. Today, 90% of the data that produced is by definition unstructured. And I think someone who is really fundamental with this notion of vector. So vector is ability to represent some information using array of number. And of course, you can have multiple dimension, and each dimension can represent a specific functionality for the data that you need to represent. And something really, and for me, it's a game changer. We finally found a way to get a standard for, I would say, storing and searching on unstructured information. And this is by using the vector. But of course, you have the source. The source is the unstructured data. You need to convert to vector, and in between, you need to use the generative AI, the LLM model, in order to do the transformation. But that's, in my opinion, a key aspect, because we finally found a way to get a standard for managing unstructured data. Regarding similarity search, so after you will have stored the data in this specific format, you will have an ability to search by similarity. So it means it is not an exact search, okay? But you have multiple advantage because you can compare text and image, and of course you can include also the context regarding the search, which is making, this notion of vector and similarity search really very interesting for our organization.
Interesting. So basically, what you're saying is we're taking an unstructured data element like a text, etc. We're using an LLM to find let's say, the semantic characteristics, the things that are in that document. We're mapping that document to a vector, right? And now when we're searching for something that is just like this vector, like a document that talks about cars and people and accidents, well, we find all documents, even if they talk about automobiles or a specific brand, etc., because now we found these characteristics in the document, or the semantics, as some say, and we're mapping them into vector positions. And then in a multidimensional space, we can find kind of the nearest neighbor to the question that we asked. That's very interesting. Yeah.
Yes, exactly. But something even, and this is where you see the power of Postgres. It's not, if you go to a vector DB, you have a specific vector use case. But the power of Postgres is that you can combine with some additional functionality. So additional functionality, for instance, if you want to link with the GIS data, okay? And another interesting aspect, similarity search, it is not an exact search, so you have approximation. And this is where you can combine the similarity search with the traditional text search. And this is what we call hybrid search. And this is something that you can do efficiently inside Postgres.
So I can look for all the documents that are like what Franck asked about and make sure that he has permission to see them and that they're currently released and that they're not due for, an update, etc. So that's really a powerful element of saying, okay, this is why we want to combine vector and traditional search to create something really powerful.
Yeah. All the organization I'm talking with, they are really considering, using the vector directly inside Postgres, because now the extension is more mature. So we have more than 7 release, and I think it's more than 20 minor release, and we have improvement mainly every month. But of course, you can combine with all the enterprise functionality that organizations are requesting, as you mentioned. So the security, knowing who is accessing what is a fundamental aspect, for inside the organization. So you cannot.
I have my same audit procedure, I have my same backup procedure, I have my same logs, I have my same patching process, everything. I don't need to hire yet another DBA for this new product. It's just like everything works. It's just it can do something new. That's cool.
Yeah, exactly.
So, and in this context, you mentioned discriminative AI, or you mentioned generative AI, and I've also heard about discriminative AI. What's the difference?
Yeah, so discriminative AI is really about making distinction. The concept of generative AI is really to learn from data in order to build new content. So you are producing something new. So, and it can be regarding video, voice, text. But you are producing something new. When we are talking about discriminative AI, for instance, you are going to classify some data into predefined categories. So, for instance, let's say about you do fraud analysis. So, and you want, for instance, to assess if the transaction will be fraudulent or not. Same if, for instance, if you were willing to put in place a system to assess if an email is a spam or not. So you know exactly what will be the output. So this is, using what we call supervised learning techniques, where you know the input and you know the output. Okay.
Okay. Good. And generative then creates something new. So that's really like, okay.
Good. Yes, and it can be about text generation. It can be, so this is why you have the emergence of the chatbot, where you generate text. You don't know what the new text will be whenever you're asking a question.
Okay. All right. So last question is, hey, I want to learn more, and I hope that many of us in our audience want to learn more. Where can I go if I want to give AI on Postgres a spin?
Sure. So it's really easy. And of course, for us, this is something where we want to support and to help. So go to the EDB website, download the EDB Postgres, download the extension. So we have, so on top of the PG Vector extension, so we are delivering now a new AI extension. So this is in preview, and the goal is really to ease the full flow from, as I explained, from, okay, I have my source data, I need to produce the embedding, so this notion of vector, and we want to completely ease the flow, and we want also to make the flow fully dynamic. So it means whenever the source table will change, automatically the vector will be generated. So the extension is available. It's a preview, so download the extension and then contact us, because we'll be delighted to help you to design the first, I would say, innovative AI apps with EDB Postgres.
All right. Well, thank you very much, Franck. That was really interesting chat. Thanks.
Thank you, Marc.